For this webinar, we have our trainer, Utkarsh Sharma, who is having 10 plus years of experience in data science, ML, DL, AI, and all the related technologies. And the best part is he's also associated with multiple MNCs like EY, IBM, TCS, Infosys, and many more as a corporate trainer. He's a PGP in Generative AI at IIT Roorkee, and he's one of the best trainer. He has trained students across all the countries globally, more than 10,000 is the best feedback. So from now on, Utkarsh sir will be taking it forward, and I want you guys to make it very interactive. If you have any questions, anything, feel free to interact anytime. Good afternoon, sir.
Good afternoon, Rajiv. Thanks for the introduction. Okay. Rajiv, can you allow me to share the screen?
On it, sir. Just a second. Yep, done.
Okay. So I hope the screen is visible to everybody.
Yes, it is.
Perfect. Okay. So let me share with all of you the agenda of today's session. In this session, we are going to understand what exactly is data analytics, how exactly we solve a problem using data analytics, what is machine learning, how exactly we solve a problem using machine learning. In the machine learning part, we will spend a lot of time because everything after that, whether it is deep learning, generative AI, agentic AI, everything starts from there. So that's where we are going to spend a lot of time. Then we will talk a little bit about deep learning and generative AI as well. And if, let's say, time allows, we will talk about agentic AI in the end as well. And then after discussing all of these things, in the end, I will also leave 10 to 15 minutes for a lot of questions. So there we can talk about a lot of applications or how exactly learning all of this can help you in your careers. So this is something which you should not really look forward to studying with the purpose of making a switch in your career, but even in your current role, all of these are going to be very helpful, especially generative AI, because nowadays you may already see a lot of influx of generative AI tools in all the industries. A lot of research is being done in agentic AI. So soon you will see a lot of AI agents being used in almost all the domains. So this is something you should look forward to being prepared for. Okay. And instead of this being just a one-way session or webinar, I would like this to be interactive. When I explain something, I would first like to know your views about it, what you think about it, what exactly you understand, what have you heard till now. And then based on that, I will share examples and help you understand the full extent of it. So let us keep it interactive and let us all enjoy today's session. I hope everybody is excited. Yes? And although you are free to use the chat or the mic, anything, but I will appreciate if we have most of the communication via mic. That way it will be rather more interactive. Okay, just to repeat, we'll start with data analytics, then machine learning, then deep learning, generative AI, and maybe agentic AI as well. So if you are interacting with me in this session, after an hour and a half, you will have a proper understanding of what all of these concepts are about. Okay, let us start with data analytics. So first, let me rather ask all of you, what do you understand by data analytics? Like, what is the crux of data analytics? It doesn't have to be a definition. It can be an application, a view, or any thought that you may have of data analytics. Please go ahead. I think some of you belong to this particular field. When I was looking at the list of participants, some of you are already into data analytics. So I will appreciate if you can participate.
So, data analytics is a process of collecting, cleaning, and analyzing and interpreting on data.
Correct. No audio. I hope all of you can hear me perfectly. Let me increase it a
Yes.
little bit more. Okay. Pani, please check on your end. I think other participants can hear me fine. Yes, Upendra, can you please repeat?
Data analytics is a process of collecting, cleaning, and analyzing the data.
Perfect. And what is the purpose? Why we analyze the data?
To understand the perspective and get some insights so that we can prepare for the next iteration.
Correct. To prepare for next iteration or to make the decisions. I hope that's what you mean.
Yeah, decision making, yes.
Yes, exactly.
Yes.
This is what.
So absolutely perfect. Data analytics or data analysis is all about analyzing data to generate insights and then use those insights to influence business decisions. So you can look at it as like a two-step process using data analytics, or you can look at it as a three-step thing. You have your data, you analyze that data. First step, you generate insights from that data. Second step, and then using those insights, you influence decisions. That's what data analytics is all about, and it is very common. I always like to say that everybody is a data analyst, uh, even if you belong to this field or not, even if you are into something completely different, still you are a data analyst. How so? Because in our day-to-day lives, all of us are already taking a lot of decisions based on a lot of analysis, whether it's about buying a new house, whether it's about buying a new car or your next health insurance or your education, your career, or maybe the education and career of your children. Whenever we make these decisions, we go through a lot of research, we analyze a lot of data, and then based on that, we make decisions. For example, if I say the decision of buying a new car. So I don't think anybody will just go to the showroom next to their house and then buy the first car they see. Definitely, this will not be the case. You will rather look at what are your requirements. Like maybe you need a 5-seater or a 7-seater, or you need an SUV or a sedan. Your budget is maybe 15 lakhs, 20 lakhs. You need a diesel car, petrol car, or an EV. Maybe you have a brand preference. Okay, so you will look at all of these things, and based on that, you will probably shortlist 4 to 5 cars, and then you will go through a lot of reviews. You will go through a lot of articles. Maybe you will ask some friends who already own those particular vehicles. And then after processing all of that, you will make a final decision that you need to buy a Maruti Baleno, maybe some other car, but that's how it happens, right? So, and then this can be said about almost all the other things that I mentioned. So everybody has a data analytics mindset. And this is why I say that this is the perfect first step to get into the field. Let's say if you belong to a non-tech role, and if just in case you are thinking about making a switch, so it may be a little bit tricky to straight away get into a generative AI or machine learning engineering, right? But it's always easy to get started with data analytics in a data analytics role because you already have that mindset. When we talk about a lot of other careers, so you may pursue the relevant education, but building that mindset takes a lot of time. I mean, if you have ever interacted with sales professionals, you will see that they have a different kind of personality. If you have ever interacted with a, let's say, a known software engineer, then you will, after just talking after half an hour or maybe an hour, you'll understand, okay, this guy must definitely be into a lot of problem solving. So that mindset takes a lot of time to build. And it can be said about several other professions as well. But when it comes to data analytics, you already have the mindset, and all you need to do is just learn some relevant tools so that you can perform it on a larger scale. Okay. So now let's take a look at what exactly this data analytics process looks like. So we always start with data collection, basically collecting the data relevant to the problem you are trying to solve. We'll look at a problem as well. This data, when we collect, it may be from a single source or from multiple sources. And the most painful fact is the data in its raw form is never suitable for any kind of analysis. And that is almost always the case. And that's why the next step is data preparation. You have to clean and transform your data so that it is suitable for some statistical analysis or machine learning modeling. Once you have prepared your data, the next step is analysis or modeling. Depending upon the problem you are trying to solve, you will use a suitable statistical technique or maybe a suitable machine learning model, and then you will solve your problem. After that, a step which is often ignored, and that is visualization, basically communicating your insights to the stakeholders, to the people who are in charge, to the people who are responsible for decision making. Now, that is a very important step because the way you visualize your insights has a lot of impact on how your information or your insights are perceived. Like there's a lot of color science involved, there's a lot of pattern science involved. Okay, you can even use them to like shift the decision making process in a direction that is favorable to you. There are a lot of tips and tricks, probably the most interesting subject. And this is truly something which is often ignored. Now, these are all the four steps. Now, they also have a lot of uh, sub steps also, but we can represent any data analytics problem uh, being solved by these four steps. Now, let's take a look at the problem or how exactly these steps may look like when we are trying to solve an actual problem. And then I will give all of you time to ask doubts related to this. So suppose the problem that we have at our hand is fraudulent transaction detection, a very popular application. So if we are trying to solve this problem, then in the data collection process, we will obviously looking forward to collecting all the data related to those transactions and also the profiles of users who made those transactions and maybe device location specific, a lot of data, right? Transaction logs, user profiles, location, device, everything. Next step, data preparation. So obviously you will not find all of this at a single source. It will be collected from different sources. So in the next step, you will clean all of that data. You will take care of missing information. You will take care of duplicate entries. You will also need to create labels for which transactions are fraudulent, which are not non-fraudulent. And maybe you will need to bring all of that to a single format. After your data is prepared, the next step will obviously be to analyze or model your data. So here, as you are talking about detecting something, regarding this, we will discuss a little bit later, but this is a machine learning use case. So here you will train classification models, which will be capable of detecting fraudulent transactions based on transaction patterns, user profiles, and everything. After that, you can use that model to communicate your results, and those results may look like, okay, out of next 1 million transactions, these many are expected to be fraudulent. These are the patterns which are associated with fraudulent transactions, right? These are the locations or time slots where we can expect most fraudulent transactions and maybe more. So this is what these four steps will look like when you are trying to solve an actual problem using data analytics. Now I will just give all of you a minute or two to recap and then ask me if you have any doubts related to what we have discussed so far. No doubt. Shall we proceed? Okay, the interaction is quite low, but I assume all of you are with me. Okay. Next, let's talk about very quickly the types of data analytics. So here we have descriptive, diagnostic, predictive, and prescriptive. So all of these four can be understood very easily using a very simple example. Assume you have a health problem, then you will obviously go see a doctor. Now, when you do that, first the doctor will ask you to describe your symptoms or the problems you are facing. So that can be thought of as similar to descriptive analytics. Descriptive analytics is about describing your data set, describing your data. Okay. Then looking again at the doctor patient use case, the doctor will then write some tests to further confirm some details. And then based on the symptoms that you have mentioned, and then based on the results of those tests, the doctor will perform diagnosis. Now, that can be, you can understand diagnostic analytics being the same. In diagnostic analytics, we are trying to identify cause of a problem. Suppose you found a problem and now you're trying to find out why exactly that problem exists. For example, let's say you see a dip in sales compared to the last quarter or maybe the same quarter last year. Okay, so there you may be interested in finding out that why exactly that is the case, why exactly there's a dip in sales compared to the last quarter or maybe the same quarter last year. That is similar to diagnostic analytics. Then the doctor will obviously make a prognosis that if this problem is untreated, then this is what the future may look like, right? In some cases, it may be very bizarre that you just have 6 months, something like that. So that's what they refer to as prognosis. That is similar to predictive analytics. Whenever you are trying to predict something about the future, like how the sales are going to look like next year, or how many fraudulent transactions can we expect out of the next million or 1 billion. So all those are examples of predictive analytics. Prescriptive, now this is not really up to us data analysts or data scientists. Here you need domain experts. In prescriptive analytics, we are trying to suggest solutions to overcome the issue. Suppose there is a particular prognosis, there's a prediction, or you're facing an issue. Now, how do we overcome an issue? That's what prescriptive analytics is all about. So descriptive is about describing your data, right? About the why, sorry, about the what. Diagnostic is about why something is happening. Predictive is like what's next. Prescriptive is about how to deal with it. So what, why, what's next, how to deal with it. That is how we can understand all of these four. Naresh, do you have a question? Okay. If there are no doubts, then let us talk about machine learning. And let us spend some significant time here. Very important topic. I will explain it in a manner that all of you properly understand it. And on this only, we will build our understanding of deep learning, generative AI, agentic AI, everything. So let me first ask all of you what you understand by machine learning. Once you give me your answers, then I will also present some definitions and then I will ask you what you think about it. Okay. What do you understand by machine learning?
Training the system for particular scenarios based on whatever data we are feeding, right? So training, making the system understand similar kind of data for different scenarios. Basically training the system.
Perfect. Training the system to understand different scenarios. Makes sense. Others? Upendra?
Yes.
Any views about machine learning?
Machine learning.
That's it?
Machine learning is guiding the machine that based on previous data, whatever insights, whatever foundings in previous data, based on that you need to do some actions for the same scenario repeat, if same scenario repeated.
Makes sense.
Yeah. Machine learning is basically setting up the approach and strategy how the system and model will learn while being in use as more and more data is collected while being in use.
Can you repeat the last part? The system and
The system and model. So it's an approach or a strategy uh, for a model to learn while it is being in use as it collects more and more data from the users.
perfect. A few more answers. Like there are some very popular definitions floating in the market about machine learning.
Basically, a system which can predict or kind of like help us to make a decision. It's not like actually programming. It's kind of like building that intelligence based on the data, so that the model can predict something or it can decide something
True.
based on the
Let's
training
say
algorithm.
predict, not decide.
Yeah, help us
I
to
will
decide.
explain.
Yeah.
Help us decide. That is perfect. That is perfect. Yes, others, Anaswara, Ayushi, David, Dave, and others also.
So machine learning is a tool that enables system to learn the data and improve on their performance over the time. Yes.
Correct. So all the definitions are correct. Let me also share some popular ones and I will ask your view. So here you just have to answer a yes or no, that whether you agree with that or not. So here's one. Machine learning allows machines to think on their own. What do you think
Yes,
about that? Is that true or not? It's a simple yes or no answer.
it is true. That's the
It's
expectation.
true.
True? All of you feel it's true? Do we have someone who says no? You can write your answers in chat as well. Okay, everybody says yes. Here's the next one. Machine learning allows machines to take decisions on their own. Yes or
Probably
no?
no. I think you only said no. It's like yes or no. Depends. But I think mostly no.
So it's actually no for both. Machines can never take decisions on their own. Machines can never think on their own. Right? It's always us. Machines can understand patterns and react based on those patterns, but they can never think, they can never make decisions. Decision making part might be true to some extent when we talk about autonomous AI agents, agentic AI, but not with respect to our plain machine learning. Right? Now, let us understand machine learning a little bit more to its true extent. Just a second. Okay. So there are a lot of ways you can understand machine learning. See, concepts like these can never be constrained to a single correct definition. Personally, I don't like to do that. But still, if I have to tell you what is machine learning, So the best way to understand or explain machine learning would be that machine learning allows us to extract patterns from data. That's it. That just contains everything. Machine learning allows us to extract patterns from data. That's it. That's all machine learning is about. Let us understand how that plays out. So the first basic requirement for any machine learning solution is data. Now we will understand the complete machine learning process. So this is how it works. First of all, based on the problem you are trying to solve, you need to have the data relevant to that. Now the data should consist of input and output both. Now what do we mean by input and output? So suppose if you are trying to solve a problem related to detecting fraudulent transactions, so you must have those details of those transactions as input, and then which transaction in particular was fraudulent, which one was non-fraudulent. So that detail you should also have input and output. If you're training a machine learning model for image recognition, so your inputs will obviously be those images, your output will be their labels. Okay, the first image was a monkey image, the first label should also be a monkey. Second image was a dog, the label should also be a dog. Loan default, the details about all the loans, income, spend, age, everything, and then in the output whether that person defaulted or not default. So that's what you mean by input and output. You need to have the data, which basically means you need to have the input and output both. Now you will feed the input and output both to a suitable machine learning algorithm. There are a lot of algorithms, so you have to choose which algorithm is suitable for your particular task. Now you train that algorithm on your data, and that algorithm simply extract the pattern which matches your input with your output. That's it. If you talk about detecting fraudulent transactions, what are the details in the transactions or user profiles that make up a transaction fraudulent? What are the pixel patterns that make an image a monkey or make an image a dog, right? What are the patterns in the loan information, or let's say the financial or personal information of a person that will make him likely to default or not default on the loan? So this algorithm will simply figure out what is the pattern which is matching your input with your output. So after training, we will get a pattern, or we also call it a model. That model basically consists of your pattern only, which matches your input and output. Now that you have learned that pattern, you can use this model to make predictions for new cases. So suppose on already existing historical data, you trained a suitable algorithm to detect fraudulent transactions. Now you can deploy that model and it will give you insights about the future, about transactions being fraudulent or not, applicants may which applicants are likely to default on the loan, which are not. Okay, or you input an image, it may recognize this is what the image is all about. There are many more applications. So this is what the crux of a machine learning process is. First, we need the data. This algorithm figure out the pattern from your data. The pattern is basically something which matches your input with your output. Now that you have learned that pattern, you can use that for making predictions for new cases. And you can clearly see we are doing is extracting patterns from data. That's it. Now, do all of you have a little bit better understanding of what machine learning is?
Yeah.
Perfect.
Yes.
Now let's go, if all of you are interested, obviously, let's go one step ahead. And I hope everybody participates. So we say extracting patterns from data, but what exactly is a pattern? That is what you learn throughout a whole machine learning course. But we would try to have a basic understanding of it today. If I say machine learning is about extracting patterns from data, a pattern is something which matches your input with your output. That's it. But there is much more to it than said. What do we mean by a pattern? What exactly is this algorithm extracting? That's the question. So let us try to understand that. See, this pattern can be in many forms depending upon the algorithm or the approach you are using. It can be a mathematical function, it can be a hyperplane, it can be in the form of a neural network, it can be in the form of a decision boundary, it can be in the form of a tree of conditions or decision tree as well. There are many ways that you can represent a pattern uh, in your data. Let's look at a few examples, because if you have a understanding of what we mean by this pattern, that will help you understand everything that is next to come. Okay, so now for a few minutes, forget about machine learning or deep learning or anything. Just think of it as a puzzle. So here is something for you. Suppose we have years of experience and salary. Think of years of experience as input, salary as output. And this is what you have. So here's a data for all of you and so on. Or let's just keep it simple to only 5 observations. For someone having 3 years of experience, the salary is 50,000, 4 years of experience, 60,000, 5 years of experience, 70, 680, and 790. Now here's a task for everybody. I hope all of you participate. So give me a way to represent the relationship between salary and years of experience. Now you can think about how exactly are you going to represent that. When I say representing a relationship between these two, so give me a way which can associate the dependence of salary, which can represent the dependence of salary on years of experience.
A ratio.
Salary is increasing year on year. This
Yeah.
increasing pattern with a certain percentage each year.
If
Or
10
conditions,
percentage
ratio
ratio of,
of salary versus years of experience.
okay. No, ratio will be different every time.
See, this is showing a pattern that every year it's a 10,000 increment in the salary. This
Yes, that
particular
is
pattern
true.
is showing that.
That is true. I'm asking complete pattern. When, okay, first let us understand
if condition,
what we mean by representing the relationship. So in mathematics, we have functions of the form this. So f of x has some dependency on x. So you represent f of x as some function of x. Okay. Now here our salary has a dependency on years of experience. So I am expecting a relationship of this format. Salary is equals to, and then how exactly are you going to figure it out based on years of experience? Like a function, an equation.
So salary equal to years. Yeah, for 3 years, 50,000, right? So naturally, like for years of experience into 10,000 plus 20,000. That may be a
50,000.
kind.
Perfect. 20,000 plus years of experience multiplied by 10,000. Now, all of you, please take a look at this. Is this the correct relationship between years of experience and salary? Is this equation representing the relationship between salary and years of experience perfectly?
Yeah. For this example,
Not
yes.
sure. Like I had a little bit different equation, but yeah, it will come down to same. I'm just doing years of experience minus 3 into 10,000 plus 50,000.
Okay, so years of experience minus 3 multiplied by
10,000.
10,000 plus 50,000.
Yes.
Yes, you are correct. It will come down to the same because if you expand this,
Hmm.
10,000
Yes.
multiplied by years of experience minus 30,000 to 50,000 minus 30,000, 20,000. So it will be the same, right? Yes. So congratulations, all of you have figured out your, basically you have learned your first machine learning algorithm. So the task was very simple. You were supposed to figure out what
One
is the
thing.
pattern.
Hello.
Yes.
How you calculated this means 20,000 plus this thing means what is the exactly thing of to calculation for this?
Very good question. Here we did simply by intuition. We just looked at all of these data and then we figured out, okay, it is clearly evident that every year the salary is increasing by 10,000, right? So
Yes. Mhm.
for 3 years, it is 50,000. So there must be a 10,000 increase every year. So for 0 years, which must be 20,000. So hence 20,000 plus years of experience multiplied by 10,000. So all of us did it simply by intuition,
Mhm.
right?
Okay.
When we try to look at this problem, we actually solved it in 2 steps. First step, we thought about how exactly we are going to represent this relationship. Okay. And then after deciding how exactly are we going to represent the relationship, then we figured out the exact pattern. What do I mean by that? First, although that I mentioned to everybody that we can represent this relationship via a simple mathematical function. So that is the first step. Second step, we were supposed to figure out the pattern. When we say the pattern, so this is your output, this is your input, output, input, and then these two are your parameters. So we simply figured out these two parameters. That is your second step. These parameters define your pattern along with this mathematical function. So this is the pattern that matches years of experience and salary. And this you created after learning from this already available data. Now you can use this equation to make predictions for years of experience, for salary given the years of experience. Suppose if someone asks you what is going to be the salary of someone having 10 years of experience. So can you answer that using this function?
Yeah.
Yes. What will be the answer?
10, 1 lakh 20,000.
1,20,000, right? Simple. 10 multiplied by 10,000, 1 lakh plus 20,000, 1,20,000. So you learn this pattern from this existing data, and now you can use this to make predictions for new cases. This is actually a machine learning algorithm. We refer to it as simple linear regression. The mathematical equation of that is y is equals to beta naught plus beta 1 x. So here our x is years of experience, y output is salary, beta naught is 20,000, beta 1 is 10,000. Whenever you have to represent a relationship between two numerical features, we use this algorithm. So that's what pattern looks like. A pattern is simply that matches your input with your output. And it can be in any form. It can be in the form of a mathematical equation. It can be in the form of a neural network, a hyperplane, decision tree, anything. And although it may take a lot of time to understand, but let me still try. There were two steps to identifying this pattern. First of all, we need to figure out how exactly we are going to represent this pattern. So that question is answered by the choice of your algorithm. So we chose a mathematical equation to represent this pattern. Now we just need to find out the parameters of that algorithm, which are found using training. Although we did it here by intuition, but there are techniques where you can estimate these parameters so that you can match your input with your output. So I hope this gave all of you a pretty good idea about what the pattern actually means. Would you like to have one more example where the pattern is not really a mathematical equation? Are all of you interested in that?
Yes.
Perfect. Let's do that. Again, but let me first give this task to you. Suppose this time your data set looks like this. We have data about income, spend, and default. So this time you have two input features, income and spend, monthly income and monthly spend. Based on that, you have to predict that whether someone will default on the loan or not. And this is already available data. Based on this, you have to create a pattern which will help you make predictions about new applicants by taking their income and spend as input. So how can you represent the pattern here between income spend as input and default as output? Think about it.
I think if the spend is more than some percentage, maybe 40-50% here approximately, I think that is a thing we need to figure it out. But I think if the spend is more than certain percentage of the income, then we can predict that the applicant may be a default case.
Perfect answer. We are getting close. So, okay, let me wait before I reveal. Any other answers?
Here it is the proportion between, it's the same thing, though he's saying, but here it's based on the ratio rather than a value.
Here I can miss if more half of that income and spend is more than half of that income, then probably it is default one.
Great. So, one thing is for sure. Here we are talking about conditions, are we not? Like
Yes.
income more than half, sorry, spend more than half of income. If yes, then this. If no, then that. Right? We are talking about conditions here. We are not really talking about functions. That is evident. And then the conditions are different with respect to every case. Like the conditions for someone making 1,20,000 are different, and the conditions for someone making uh, 50,000 are different. Yes or no?
Yeah.
So, can we solve this problem by using multiple conditions? Or like a tree of conditions. Conditions are also referred to as decisions, by the way. So, like a tree of conditions. Can we do that? Yes, we can. So, basically, the point is here we are talking in terms of conditions. Second, there is no single condition which fits everywhere. Okay, so we have to think of multiple conditions. Now, let me show all of you something, and then you tell me whether it is satisfying all of these cases or not. Have a look at this simple flow chart. In each box, I have mentioned a condition, income greater than 1 lakh, and then there can be two results for that condition, either true or false. Then we have one more condition, again true or false, and we have one more condition, again true or false. And then at the end, we are making some predictions. So you tell me, is this set of conditions or tree of conditions satisfying all the patterns in our data? Take a look. The way to verify that is just put income and spend income as input in this, and then
Probably
see.
no. I think the first two, three cases it might not fit in, wherein the income is definitely less than 1 lakh, but we are just checking greater than 5,000 only.
It's 50,000, not 5,000.
Oh, sorry. Oh,
It's
sorry, sorry.
50,000.
Okay, okay.
So I was saying the way to verify is just put income and spend as input here and see where you land. Finally, where you land, that is your prediction. So see if it's giving you correct prediction for most of the cases, or maybe all of the cases.
Go on mute and talk louder.
Verified?
I think it is falling.
Others, have all of you checked this? It definitely is. So here we simply have like a tree of conditions, right? We also call them decisions. So at each step, we are making a decision whether to go left or right. So this is also known as a decision tree. And congratulations, you have understood the most important algorithm in machine learning. A lot of algorithms are based on the basic concept of a decision tree. So we started by realization that here we need to think in terms of conditions. That is the best way to solve this problem. So here it is. You can go even more deeper. You can apply more and more conditions to be more accurate. But I hope this example helps you understand that a pattern can exist in this way only. So here again, you are matching your inputs with your output. Like if income is this, output out spend is this, then the outcome might be this. So this is nothing but representing a pattern of this data set. If the data set is different, then the pattern might also be different. But for this one, this is perfectly representing the pattern with respect to who will default, who will not default. And now you can use it for new cases as well. If you have any new person with an income and spend, which is not part of this data set, a new applicant, basically, for him or her, you can predict whether he or she is likely to default or not. Yes means default, no means not default. So this is another way to represent a pattern. Similarly, you have many other ways as well.
This is something like flowchart also, right?
Yes, exactly. Decision tree is like a flowchart.
Yeah, but the only difference is that in every step we are making a decision, whereas in flowchart we are executing processes also. But
Right.
here,
That
pretty much
is
we are making a decision.
the perfect way to separate the two. Here, every node represents a decision or a condition. Whereas a flowchart, basically you can do anything.
Utkarsh, can we also have an example of a neural network kind of pattern, or basically
That will
what that
be
is?
a bit tricky because that's really huge. Like we cannot think of an example which can help us understand a neural network in just
Yeah, Peter.
this way.
But will you be able to just later on, maybe in the session, are
Yes,
you
yes.
planning
After
to
machine
explain what a
learning,
neural network is?
yes. After machine learning, the next is deep learning. That's where you will understand what a neural network is. Although I will not be able to explain its architecture, we need at least an hour only for that, but we will understand the basics.
Sure.
Okay. So this is what machine learning is, and then I also try to explain what a pattern might be. And then based on the algorithm you are using, the pattern can be anything. Shall we proceed to the next concept?
Yes, please.
Okay. Now let us quickly, I think we have already discussed the important part. Let's quickly have a look at what are the steps involved in a machine learning process. So the first two steps are the same. You first collect the data relevant to that problem, and then you prepare that data so you can actually train a machine learning model. The next step is to choose a suitable algorithm to solve that problem. The kind of algorithm you select depends on the nature of problem you are trying to solve. Once you have selected an algorithm, you train a machine learning model, and then you evaluate the performance of that model as well, because before you can think about putting it to use or you can think about deploying it somewhere, you should evaluate whether it's doing a good enough job with respect to the task or not. If yes, then go ahead and deploy that model into production. So data collection, data preparation, algorithm selection, training and evaluation, and then finally deployment. Let us proceed. So after machine learning, let us talk about deep learning. Again, let me rather ask all of you first. Do you understand what is deep learning, or has anyone heard about this? No. Okay. So we have already understood what deep learning is. How so? So most often new learners have a feeling that deep learning is something very different from machine learning, which is not the case. Deep learning is the same, extracting patterns from data. That's it. Deep learning, whatever I explained here, algorithm input, output pattern, then input model output, this applies to deep learning as well. But there is just one difference. In machine learning, we have a lot of algorithms, a lot of classical algorithms, okay, decision trees, uh, support vector machines, naive bias, regression, k nearest neighbors, okay, random forest. A lot of different algorithms are there. We call them classical machine learning algorithms. In deep learning, we are only talking about neural networks. That is the difference. Neural networks are also doing the exact same thing that your machine learning models are doing, which is extracting patterns from data. There is no difference. Right? Neural networks are much more flexible in extracting patterns. They are able to extract patterns which are complex in nature, on which the classical machine learning models might fail. But we need to have a very important discussion. If neural networks are better, which they definitely are, then why don't we just use a neural network for every problem? Why do those machine learning classical algorithms still exist?
Is it something to do with the input data?
Not to do with the data
Resource?
And
exactly.
Resources.
is it anything to do with the infrastructure required for this?
Yes, absolutely. Okay. So this is a very important question, and I always explain this using this analogy. So think of machine learning as a knife and think of deep learning as a chainsaw. So if your task is, let's say, to cut fruits and vegetables, what will you use?
Knife.
A knife. Can you use a chainsaw? Yes, you can. No one is stopping you.
But
But
it's overkilling.
right, it will require a lot of energy from your end, right, to carry and to like cut a lot of vegetables using it. I can visualize it actually. And obviously that consumes energy in other ways also, like electricity, charging, or maybe direct power source, whatever it is. So
Resources.
definitely it's not the best tool for the job, right? Now the second task, if you have to cut a tree, then what you will use?
Chainsaw.
Chainsaw. Can you use a knife? Yes, no one is stopping you. You can
No one is
go.
stopping, but a lot of effort and results, time,
Exactly.
the result might not be the same, probably.
True. You can take a knife and you can keep on chipping slowly, and then maybe in 3 days you will be able to cut your tree. But again, that's definitely not the best tool for the job.
Yeah,
Based on complexity, you can say
this
whichever.
analogy is going to help us in many other ways. Yeah, good one actually.
Right. So that's how it is. I mean, this question may not have popped because, let's say, we have not discussed machine learning, deep learning in much more detail. But whenever we study these things in detail, when the deep learning module starts immediately after machine learning, so all the participants of the course, I face this, they are like, oh, neural networks are so great. You don't need any pre-processing. You don't need anything. You just throw a neural network and it's able to do all the tasks. This is so good. Why don't we use this always? And then I show them the cost it incurs of that large GPU infrastructures. And then when they are not able to run a deep learning neural network in their PC, then they understand, okay, that's why, right? When they feel that just to run that neural network and to actually create a project, they need to pay something. That's where they realize, okay, we are good with machine learning. That's how it is. So the bottom line is, when you have tasks which are a little bit simple in nature, which can be accomplished by your classical machine learning models, so obviously go ahead and use that, because neural networks are huge. They have millions, billions of parameters. Nowadays they have trillions of parameters. You can't even have a neural network in your main memory, let alone be the data. And they require large amounts of data, and they require trainings for a longer period of time, and that training requires GPUs, which are very costly, right? So that's why, if the task is simple, if the pattern can be extracted by a classical machine learning model, use those. But if the patterns are complex, then use, and obviously use a neural network, right? Now, but still, is there any guideline when to use what? Yes. So we have structured data and unstructured data. Structured data is basically data that exists in tabular format, rows and columns. We are talking about Excel sheets, CSV files, pandas, data frames, SQL, RDBMs, tables, all of those things. That is structured data. And then we also have unstructured data. Unstructured data, we mean images, text, audio, video, all of these things. So if your task involves structured data, think of a machine learning approach always first. If your task involves unstructured data, think of a neural network based approach. That is a guideline, but it's not the case that machine learning cannot be applied to unstructured data. You can. It's also not the case that deep learning cannot be applied to structured data. You can. But when it comes to getting started, these projects are always experimental in nature. You try with multiple algorithms, multiple approaches, and then you decide to go ahead with which gives you best result. So if you have structured data, always start with a machine learning model. Unstructured data, always start with a neural network. If you feel like simplest of your neural network is giving you good results, then you know the pattern is quite simple. Then maybe, if it can be solved easily by a very simple basic neural network, can it also be solved by most sophisticated machine learning algorithm? Try that. That's how it works. Now, we can't really do justice to the neural network architecture in the short amount of time, but I will give you an overview. In neural network, we basically have a lot of layers and neurons. So this is your very simple neural network. Here you receive your input. Here you have your output. That's what a neural network looks like. Now, each of these neurons you see, they have some parameters. They perform weighted sum and apply an activation function, or you can simply say they just do some processing, right? And then they finally produce your output. Each of these has parameters associated with them, depends on the number of inputs. So suppose if number of inputs are 4, so this will have 4 weights, 1 bias, total 5 parameters. This one will have 5 parameters. And as this one is receiving 2 inputs, this one will have 2 weights plus 1 bias, 3 parameters. So this simple neural network for processing 4 inputs has 5 plus 5 plus 3 parameters, right? 13 parameters. So now you will train this neural network to learn best values for these 13 parameters so that it learns to match your input with your output. Like earlier we did with that one single equation. Here it's a multi-step process. That's what a neural network is. This is a very simple example. They can be very large as well. Suppose you have a neural network that is trying to learn to detect images and your images are full HD RGB. So the number of inputs you will have with respect to a full HD RGB image. So full HD is 1920 by 1080. Let's make it 2000 by 1000. So total 2 million. And then it's RGB. So 2 million by 3, 6 million. And suppose in the first layer you have 500 neurons. So each one will have 6 million weights. 6 million by 500. How much is it? 3000. 6 by 500, 3000, then million. So 3 billion.
30 billion.
30 billion or 3 billion? Check again. 6 million multiplied by 500. How much is it? I think 1,000 million is 1 billion, right? Am I wrong? I think I'm right. So 3 billion, 3 billion parameters is what we are talking about. And I'm not even talking about 4K images. I'm not even talking about very high resolution geospatial images for which these neural networks are used. So just one layer has 6 billion parameters. Sorry, 3 billion parameters. That is huge. Now you train that to learn the best values of all of these parameters. Like in our equation, just a second.
I
Like
think
here, we
around
learn
3
the best.
trillion. The answer is
Yes.
3 trillion.
No, it can't be 3 trillion. Just a second. Now all of you are
6,000 million,
confusing
right?
me.
6 million. So 6 million, huh? Sorry.
I'm right. It's 3 billion only. It
Uh,
doesn't matter. It doesn't
yeah,
matter. You all of you get the picture, right?
yeah, 3 billion,
Basically,
correct.
the picture is it's huge.
It's huge.
So
Unimaginable.
here we were talking about learning best values for these two parameters, our beta naught and beta 1. Here we are talking about learning the values for 3 billion parameters to represent the pattern between your input and output. And that I hope gives you an idea that why they are so resource hungry, right? And nowadays, when you have applications like ChatGPT and everything, they use LLM. So they are using trillions of parameters. Trillions, actually trillions. So this is a little bit about neural networks and deep learning, nothing different. You are just talking about neural networks instead of classical algorithms, and that's what deep learning is. Shall we proceed to generative AI? Any doubts related to deep learning?
Yeah, just one doubt. So can we say this neural network is more accurate and as it's using deep architecture and everything on top of deep learning?
Although, in short, I can say yes, but there is more to it. It's not like it is more accurate, but rather it's about what kind of patterns it is capable of understanding,
Mm-hmm.
right? For example, on some patterns, your classical machine learning algorithms may completely fail, like they are not able to do anything. But a large neural network may be able to extract that pattern. So it's not about being more accurate, it's about the capability. But
Okay.
yes, let's say if you have a medium level task which can be performed by a machine learning algorithm, also by a neural network, so you can expect the neural network to do a little bit better than the machine learning algorithm, if that's what you mean.
Okay. Yeah. Thanks.
Okay. Let's look at some of the applications. Now, I think all of you are already aware about all of these things. Let's not spend much time here. So, deep learning and neural networks, they can be used for image classification, object detection, chat bots, sentiment analysis, voice assistants, transcription. I hope I saw your profiles. I mean, your job titles. Most of you are senior executives, so you might be using a lot of those assistants, meeting assistants when you join your meetings, which after the meeting send you an email and you can see the transcription or summary of the meeting, right? So those are also possible because of neural networks. Recommendation systems on e-commerce sites, you may have seen like customers who purchase this also purchase this. The recommendations you receive on OTT platforms, they are also made possible because of these. Self-driving cars, robotics, okay, all of these things, even a simple feature as self parking, they are all also possible because of deep learning only. Any particular application that you would like me to explain here? These again are just a few of them, not all. There are many more applications of neural networks. Auto completion is something that you may have come across very often. You are writing an email and then it auto completes things. Even when you are writing code, if you have someone from technical background, we have auto completion nowadays. So all of this is made possible because of deep learning and neural networks only. Okay, let's talk about generative AI. So first of all, let's understand what generative AI is and how is it different from what we have been talking about till now. So till now we talked about applications such as, let's say, making a prediction, classification, detection, recognition, transcription, all of those things. Generative AI deals with generating new content, like generating text, generating video, generating images, generating audio. Okay, and I think last 1 or 2 years have been all about generative AI,
Hmm.
maybe even three. You have tools like ChatGPT, DAL-E, Stable Diffusion, and then every company has their own Gemini, Grok, Llama, Cloud, all of these things, and then everybody is just going gung ho about all of this, right? So that's what the base is. Generative AI is about generating new content. It can be text, audio, video, images, anything. It can be code also, right? But the principle here is also same, but it's just much more large scale in nature. Chat GPT is able to generate text for you because the underlying model, which is a large language model, it has been trained on a lot of data that is available on the internet. A lot, we mean actually a lot, right? It has learned the patterns from that data, and now because of that only it is able to generate new things for you. Same can be said about any model that generates images and audio, video, anything. They have been trained on a lot of data like that. They have understood the distributions, and based on that pattern only, they are able to create new samples. So that's what generative AI is. Learn data distributions from already existing data and then create new samples. In basically, there are a lot of neural network architectures which make generative AI possible. There are generative adversarial networks, variational autoencoders, diffusion models. Okay, uh, there are transformers, and most importantly, large language models. That's what we have in trend these days. In short, we call them LLMs. All your applications like ChatGPT, they all are powered by an underlying large language model, which is not something very different. This is what it looks like. So let me just present the hierarchy. I hope we're running out of time. You have machine learning models, then a little bit better deep learning models, which are of different kinds, neural networks. Then you have some more techniques, self-attention and everything. You have something called transformers, and then all of these things. And using those, you create your LLMs. So LLMs are made up of transformers. Transformers are basically a neural network architecture, a building block for much more larger large language models. That's what the hierarchy looks like. So this is where we are. So these are very advanced. We even have multi-model systems. So multi-model means something which can generate text also, video also, image also, audio also, everything it can do. That's where we are. Okay, how they are trained. There's a whole subject behind that. But to simplify it, they are trained on very, very, very large data sets using very specialized techniques to extract the patterns. Applications, anything that involves generating text, generating images, generating audio, generating video, generating code, or anything that you can think about. All you need to do is just train them on relevant data, and they will, and use a suitable LLM, they will be able to do the job. Let me quickly tell you about Agentic AI as well. Sorry, in the end, I had to rush a bit because I have to leave 10 minutes for Rajiv as well and some questions as well. Generative AI is about generating new content. If you add tasks also with that, okay, when you add the ability to perform tasks, that's what we refer to as agentic AI. So we have AI agents, they are able to perform tasks. So in the last 2-3 years, all everything was about generative AI. Now the next few years are going to be all about agentic AI. Some companies are even targeting something called AGI, augmented general intelligence, which is supposed to be even more intelligent than us humans. So that's where everybody is investing these days, agentic AI. And you may have already seen how useful these generative AI tools are. They still require a lot of your intervention. Soon you will have agentic AI tools in almost every industry, almost every domain, which will make your lives much more easier. But you definitely have to take a step in learning towards them. Okay, the shift is already there, and soon there will be huge influx. So you have to be prepared. And although there's a lot of hype that AI is going to replace a lot of jobs, I do not believe that. See, whenever something like that comes, there are actually new roles that are created. These things come to reduce the manual labor. A lot of things you might be doing manually, boring, mundane tasks. So these will be able to take care of that. But definitely you will have be to keep yourself up to date with the relevant technologies. And hence, learning about machine learning, generative AI, agentic AI, it's not just essential for those who are making to switch a career, but for almost all the professionals. Okay. Now, if you have any doubts related to what we have discussed in the end, or anything in this webinar, please go ahead.
So Utkarsh, one question. Right now you said agentic AI and then AI agents. So is it an interchangeable things? Because we keep hearing.
Agentic AI is the, you can say, name of the field, name of the domain,
Mhm.
and with there you create AI agents.
Okay.
Like robotics and robots. Right? Robotics is a
Okay.
field where you create robots. I hope it made sense. So agentic AI is like a field, and that's where you create AI agents.
Okay.
Okay, good question by Pratyush. So Pratyush, data science is basically all about data. So when we are talking about applications such as data analytics, machine learning, deep learning, they all need data. Now, when you need data, you need tools and techniques to store data, retrieve data, manage data, okay, to pre-process data, to analyze data, to visualize data, okay, to model data. That's what data science is all about. Everything related to data comes under data science. You have seen, like we have seen data analytics, machine learning, deep learning, AI, generative AI, agentic AI. What's the most important part here? Data. As data powers so many things, you need tools and technologies to store data, manage data, pre-process, model, visualize, analyze. So all of that comes under data science. Here? Okay. Other doubts? Okay. So ML ops and data science ops, just a second. Remember when we talked about machine learning, I talked about the last case, which was about deployment. So after you are trained and evaluated, then you deploy and monitor your model. So that is where ML ops comes into picture. If you're dealing with AI models, neural networks, then we simply refer to as AI ops. It's about deploying and monitoring your models. That's where you need DevOps. So if you have DevOps with respect to machine learning projects, you call it ML ops. If you have that with respect to AI projects, you call it AI ops. It's like that.
Yeah, so that's where the confusion is AI ops versus ML ops, not able to exactly map.
Interchangeable. These are just different terms. So as I said, if you are just thinking about deploying a machine learning model, okay, ML ops. But if you are using DevOps to handle AI projects, then you call it AI ops.
Okay.
No other doubts?
No, thank you.
Okay, then. So I hope all of you got a pretty good idea with respect to all of these, and this session was helpful. I wish I had more time. I had to rush through a few things in the end, which basically I planned a lot more to discuss. But anyways,